peaceful now. It's
Yeah.
peaceful. It was clear that public holidays are over here.
Mm.
From one call to another,
Oh,
everybody's waking
goodness.
up again. Yeah.
Oh well. How long have the holidays been going on?
Normally here it's July, August. Now there is a little bit difference between country to country,
Mm-hmm.
and also the students. Now July, August is not for everybody, yes, especially for children, for students.
Mm-hmm.
People who work have at least 3 weeks a year, and then as you get older, you get more. But I'm my own boss, so I'm always on holiday.
Yeah. Or never on holiday, whichever way you look at it. And you always have to
I,
keep people
I
happy.
no, it depends how I do what I like. So
Mm-hmm.
uh, work is a little bit like holiday for me.
Yeah.
Um,
Isn't that the phrase? If you do what you like, you never work a day in your life.
something like that. I find working is more relaxing than going on holiday.
Mm.
Um, if you go on holiday, it breaks the routine, and then a lot of things happen, and uh, it brings more stress to be on holiday than to work.
Yeah, that is true. That is true. Yeah, especially if that holiday includes coordinating with other people that you don't always coordinate with. So you're going to visit family, and it's like, okay, we have to figure out what their routine is and how we all
Mm,
fit that together.
yeah, but yeah, tomorrow morning early, I'm leaving for Belgium. So
Mm-hmm.
for the rest of the week, helping the daughter move again. She's gonna continue studying in Belgium now. So yeah, it's gonna be a hell of a week.
Oh yeah.
Okay, I could still make it so that I was here today. So
Well, I appreciate that.
at least,
Mm-hmm.
no, I appreciate it. I like to. Good. How was your holiday last Monday?
Oh
Last
yeah.
week you had.
Yeah, exactly. Yeah, so it was. Honestly, I thought it was a really good start to the holiday to go ahead and wake up and have our
Mm,
conversation, and then otherwise I would have just been sleeping through that part of the day, and I got up and I got started
mm,
on things. Um, so yeah, it gave me an opportunity uh, to get a few things done around the house before going out and grilling um,
mm.
and just spending time with the family. So it was pretty fun. Really enjoyed it.
I saw some. I saw now that you say grilling. I saw some pictures on Twitter.
Yes, yes, yes.
I got really hungry.
Yeah, yeah, yeah. Yeah, a few of my friends make bacon wrapped jalapeno peppers and bacon wrapped dates and all sorts of bacon wrap stuff. And I was like, I have not actually done that before, so I gave that a try.
Mm.
And yeah, I think I'm not quite perfect at it yet. I'm just going to have to keep practicing.
It,
That's
it looked not bad to me.
yeah, that's the price I'm
If
going to
you
have
would,
to pay is just to eat more bacon.
if you would live around here, I would have paid you a visit. No, it's something. It's not a common dish over here, but it looked delicious.
Hmm.
So I had not the impression that it was a failure. Not at all.
No, no, no.
Mm,
But there's always room
mm,
for improvement, and that's just an excuse to grow more bacon.
yeah, that's a good excuse. All right. The code. Um, I've been digging into it further, and
Hmm.
it keeps being difficult. I think what the thing that's difficult for me it's quite abstract.
Hmm.
I think it has to do with the fact that you are used to build compilers, perhaps not build compilers, but for example the factual language compiler at the
Right.
time.
Yeah.
I understood that it's something that you've been involved quite a lot. And also this code, it's quite abstract, um, and it's not really easy to find out what the purpose is of all the objects. For example, a collector, an emitter. If you dig into, you say, okay, a collector, it will convert a runtime fact into a real fact, and it will add a graph to it. The emitter will do the opposite thing. Then all the data structures to see what do we really need and which part of the data structure is used for performance reasons. That's not easy. Would it be useful to document these objects as I go through it, or do you say no? I'm going through it. I want to understand it. It takes.
The thing that I think will help. Let me go ahead and do a share so we can see what we're looking at.
I might not be the last one who wants to understand it. I hope so. And so it might help perhaps if I try to document a few things along the way.
Yeah. So I added. Okay. Yeah, I have two documentation folders now. I realize there's one that's up here on the outside, which is the notebooks. This one right here inside of Janaga, this is where I started documenting the parser. So yeah, it's really
that's not readable.
Yeah. Okay, well, let's go ahead and zoom in and we can look at. So, and I think this is actually a bit out of date, but the idea here is that we've got we've got two steps. This is this is basically what the product looks like. So a pipeline with its various steps. Yeah, this is definitely out of date because step used to be a base class, and you had predecessors and successors that were both steps, and conditionals that were steps. And then this was the set of parser classes and how they're all related. Yeah, I was when I created this, I was starting to kind of suffer with the oh, I'm not showing this on the stream. There we go. Yeah, so when I created this, I was trying to figure out which belonged in which bucket, because I kind of saw myself crossing the streams a bit. So so let's pretend that this is up to date. This one's probably not too badly out of date. Yeah, this looks pretty recent. So so what's happening inside of the parser is we're going through iQueryable, and this is a Linq query provider, and so it's parsing expressions and turning those expressions into symbol values and putting them into a symbol table, so that when you reference something as a variable name, it pulls it from the symbol table. So that's basically emulating that code by storing it there. And so the types of symbol values that you could have are a set definition or a composite, and now a collection. But those were the two types of symbol values there could be. So a composite is a symbol value that looks like an object that has properties, and then each one of those properties is another symbol value. So it's like the symbol table is all of the local variables, and then symbol value composite. All those names are properties of an object that's in one of those local variables, or further in one of those other objects. So those compose. So that's the composite, and so that's why you've got this this arrow many, because a composite contains many symbol values. And then symbol value set definition, that refers to a particular set definition, which is the initial, so facts of type X, that's set definition initial, or where's the next one that's important? A set definition join. So the very next thing that you have to do after facts of type X is you have to say where, and so you join that set definition to some other set definition that's already been declared. Mm-hmm. And so you do that through these chains of roles. So a bunch of a.x.y equals b.w.z. So those are the two chains of roles on the left and the right of the equal sign. So at that point, it doesn't know which one. It just knows that x, y, and wz are predecessor relationships, but it doesn't really put them into order to say, okay, here we're going up the predecessor chain, and here we're coming back down the successor chain. It doesn't know which way it needs to turn it, so it's just capturing that information. And then that creates that set definition join. And so then we've got the conditional that also looks like a where, but it's a where that ends up just operating on one of the set definitions. So it ends up being existential, where any or where not any. And so that has the condition definition.
But why does that one has two arrows going up to the set definition?
Yeah. So hard to see here, but this one is the open triangle. So that is a set definition. Conditional is a set definition. But this other one is a solid arrow, and that means that the set definition conditional contains another set definition. Mm-hmm. So it's the dot any, but that's around a child set definition. So there exists something like this, and so that knows whether it exists or not exists. Let's see, condition definition. Wait a minute. That's got the arrow. Yeah, that might be a mistake. That might be the actual arrow, and this one is just inherited from that. Yeah. But it's really the condition definition that has that child's set definition inside of it. So you parse the iQueryable, and you come up with this graph, which is it's really close to an abstract syntax tree, except it knows a little bit about the constraints of the syntax. It knows that you can only use these things inside of that link. Anything else, it's going to throw not implemented exception, and eventually have a reasonable error message. But so you run the parser, and you get back ultimately one set definition at the top. And then you have to turn that set definition into a pipeline. So this is a little bit different. It used to be that there was a separate projection definition, but now it's actually, the projection is captured as a set definition as well. So then walking that abstract syntax tree and figuring out what it means, and then turning that into a pipeline, that's a completely separate step. And so these dotted arrows mean that the condition definition generates a conditional step. Projection definition generates a pipeline. And this graph is wrong now, but there is a graph on that side that's meaningful. And when I first started creating this diagram, it was because I noticed that in code, some of these classes depended upon these classes. So I was just simply taking abstract syntax tree stuff and putting it into the pipeline stuff. And I said, no, I want a very clear separation there, especially when computing inverses. I'm not going to compute an inverse by referring back to the syntax that generated the original one. I mean, that's just, I want this to be a completely separate abstract data structure. So, all that to say that as you go through that exercise, keep in mind these the separation of these classes. That might help to orient yourself.
Yeah, so the left one is not really up to date.
That's right.
The right one is. Okay. That might help a little bit. I will print it out big and put it on my desk.
Okay. Yeah, and also as you work on that, it might be useful to update that documentation. Although, while I'm working on yet another modification to the pipeline stuff, might be good for me to update that documentation too.
Mm-hmm. What is the new development?
Yeah, so it has to do with the projections. Actually, I'll get back to sharing again, because that's going to be important to see here. All right, so if we go to, let's make sure that all of this is actually working. So first of all, I'm going to .NET builds, and we're looking at Janaga GraphViz. Okay, so now I can run all those. Oh, it's got a merge in there.
I have conflicts.
All right, let's go with people and families. Yeah, I think this is the more interesting one. Okay. Yeah, so that's working. And I think this one is, this one is old syntax, so let's, in fact, that's all up there. So I can just get rid of this whole block. All right, so this is all in service of being able to do facts.all. So so here I've got people in family. So given a family, match person of type person, where person family is family. And then select the person, and then the names, which is all the facts, names of person. And so the specification for that is up there. So that's the name where the name is current. So starting to get some composition happening. So you can take a specification and use that inside of another specification. Kind of interesting thing, bit of a side note, but kind of interesting from what we're talking about here, is that in Linq, iQueryable is the unit of composition. And I definitely have iQueryables running around in here. So like facts of type person is an iQueryable. And that's how query providers work. But I found that iQueryable was not quite enough composition for what we're trying to do with Janaka. So if I say if I were to just do this using iQueryable as the composition, then I would end up with this this iQueryable of person name, and the person parameter would be captured within that iQueryable. Or I could add it as a where clause at the end, and then generate a new iQueryable that captures that person parameter. And so here this would be names of person dot where person dot person equal, or name dot person equal person. I would put that where clause right there, and then at the end I would get back an iQueryable. And the only thing that you can do with an iQueryable is turn that into a collection. You can realize it. You can execute it. But in order to do these watches, I wanted to have unadded. And so names doesn't come back as an iQueryable. It comes back as an iObservable collection. And so that's what facts.all is all about. So yeah, that's why different level of composition than just iQueryable. But you also have iQueryable as a level of composition, so you can do all of the fun stuff that you will sometimes do in Linq, where you have a function that takes an iQueryable, returns an iQueryable, and it can add some new where clauses and all that fun stuff. But okay.
Then it gets complicated.
Yeah. Well, the whole point of the composition is, hopefully, to be able to take the complication that has to be there to solve the problem and abstract it, to put it behind something that has a name that now you can refer to. So names of person. You should be able to just forget what names of person means and just say, okay, I've done this other work up here that I'm really thinking about, and then I need the name of each one of those people. And so names of person is the specification that gets you back.
Sometimes it does help, but sometimes it depends a little bit on the naming.
Yeah. If it weren't for the composition, then you would have to take all of this code and stick it in there, and it and even that still wouldn't help, because again you'd now be composing with iQueryables, because facts of type gives you back an iQueryable, and so that's what you would end up with in names instead of an observable collection where you could do a dot unadded. So what I have been working on, let's just say, let's take a look at who are the people in your family. So people in family that I want to take a look at the pipeline and to descriptive string. So the pipeline for people in family is just starting at a family, walk the path to a person, following the successor. So from family, take the successor along the family roll to get the person. So that's pretty much it, which is just this part right here. It doesn't know anything about the names of person inside of that pipeline. But if you take a look at the projection, then you tell a different story. So now the projection is the person, which was labeled inside of the pipeline, so we know that produces an element of the tuple in the Cartesian product, and so we can pull that out, give that the name person. And then this array, so now I've embedded the child pipeline inside of the array syntax there. So And it doesn't have a starting point because all of the labels that are used inside of this pipeline are already labels that are picked out in the parent pipeline. So you already know what person means. So that means starting a person, you can take successor along person to nested person name, and that gets you back your name facts, and then where not exists a next person name, where that's pointing back to name as the prior, and so that will give you, and now that pipeline now has a projection, just pick out name, and so that projection becomes, that now then populates that as an array or an observable collection, really, of those facts, and that's what names ends up being.
Okay.
So I've taken pipelines, put them inside of projections, and so this is where that new type came from over here that I was talking about, where we've got symbol values. So each of the elements of a projection is a symbol value. And actually, this is one place where I am starting to cross the streams a bit more, a bit again. So I think I want to solve this problem. But so you've got the symbol value composite, which is this thing out here that has a names and a person, or yeah, a names and person field. And then each one of these is a symbol value. This person right here is just a symbol value set definition, so it's pointing back to that set definition that was in the that produced it. And then this other one, this other one here is a symbol value collection, which is not on the graph yet. And that's what composes, and again has its own pipeline and projection. So things getting even more complicated, but I feel like it's approaching the right level of complication. This gives me all the power I need in order to express the family of queries that I would want to be able to express.
Yeah, it's quite abstract. We are far from the simple facts that you define. Although it's just a translation of it, huh?
Yeah, and what I expect is that here let's go ahead and do the pipeline plus the projection, and actually I don't think I've got the carriage return line feed in there. Oh, I already did. Okay. Yeah, so let's look at those two together. So this is the set of information that that you have whenever you want to run a query, and then when you take the inverse of this, then it's going to take both the pipeline and the projection now to take the inverse. Whereas before, all the information that you needed was up in the pipeline, so you could ignore the projection while taking an inverse. But now we have to combine those together. But first of all, let's talk about execution. So if you were executing this with a SQL database, you would do, like here, in order to execute this part, you've got your person ID in order to identify your person record. And so now you're going, so up here you've said that person has an alias person, so labeling the type. So now this, by the way, isn't going to be the actual SQL that you would use in the query provider in the storage engine, because the storage engine is application agnostic. This is if you were to completely translate this historical model into a SQL model, this is what you would end up with. And then this here becomes the where clause, because you've got the family that you're starting with. So that's your where person dot family ID is equal to the family ID parameter that you're starting with. And so that is the query that gets you this person record. Now, here you could get all kinds of fancy, and you could do a subselect. Like here, you could do a left join. Actually, here you don't even have to get fancy and do a subselect. You could just do a left join to the person name. But now what you're doing is you're kind of optimizing as you go, and you're saying, you know what? I can see that this is only one more level down. It's pretty straight. I could just do that as a left join. If this were a more complicated pipeline, I would do that as a subselect. If you had multiple collections inside of your composite, then you would have multiple subselects and things would get really crazy. So let's not even go there. Instead, where we're going to go is every time we see a collection, let's just do another query. So now let's combine these two pipelines. So I'm going to select what I'm ending up with is name. So I'm going to get name.name ID. And so it starts the same place as up here. So let's grab those. But now we're focused only on this collection. So we can go ahead and dive into it. And we don't have to do a left join because we know we've already gotten all the parents up here. So we can just do a join. And now that's where we're going to label the name. That's person name. And that's and now this join right here becomes the on clause. So that's name.person ID equals person.person ID. So that's what the successor in the person role means, is we're using the person foreign key. So I've got the person name, and then here this not exist clause, well, that does turn into a subselect. And so not exists, select one, and so now we go and label this thing as next. So from person name, and we label that next, and then we put this join into this where clause. So you do have to figure out, does this join end up as a where clause or as a on clause? And that's just contextual. And so next dot prior is equal to name. So just turning that into that. So these two queries now will give you two result sets. This one's going to have every person that's in the family. This one is going to have every person in the family and their candidate name. So if they have multiple candidate names, then you'll get multiples there. If they don't yet have a name, then you get no results there. So you need to be able to join these together. So there's one more thing.
some ID.
Yeah. Yeah. So now, once you get back these results, then the code can feather them together. Which, by the way, if you have tried Entity Framework, like in the .NET 4, so EF6, that era, versus Entity Framework Core, then you would have noticed a huge change in the way that they generate queries. In the past, if you were to do something like this, where you have multiple collections, and you're trying to compose those together inside of one composite, it would generate a query with a bunch of subselects. So you get back a single result set that has these these rectangles in it of the child records, and then everything else is null around them. So this really huge result set that's sparsely populated. And then they said, you know what? It's a lot more efficient to return multiple result sets. So now they actually generate these multiple queries. So if they've decided to do it that way, I think that's probably a good good support for us doing it that way too. So that's what this modification supports. But that does now mean that when I give the query execution engine something to work with, I am going to have to give it information that comes from the projection. Whereas right now it doesn't know anything about the projection. It just returns Cartesian products, and then the code takes those Cartesian products and turns them into projections. But at the very least, the good part is that I can give it a whole bunch of pipelines. Basically, I can take this pipeline and this child pipeline, and I can compose them together. So I can give it the pipeline that's just start with family, do this person path, and then do this name path with this not exists. Just give it that composed pipeline, and then it will generate this query here. And then the thing that called the execution engine can now take all of these results and put them together. So it's not too much work on the query provider, on the storage engine.
Actually, this will have to be translated into general SQL queries to access the database.
Yes. Yeah, so if you want to generalize this, then basically every time you are identifying a specific type in the query like this, instead, what you'd really be selecting from is the edge table. All of these queries just go against edge. Yeah, you're going to label edge, give it different names, and then have joins edge to edge. So then you'll have to add another part of the where clause. So like where person edge, successor type is person. So it's always the successor type that gives you that label. And then the other part of it, that's either the where clause or the on clause, based on where you are in the in that generation process. That's going to be the successor of one equal to the predecessor of another. Is that right? Something like that. It's the closest that I have to that kind of logic is in Janaga.js.
I took a look at it. to see how it was implemented in Postgres SQL. We'll get there finally.
Yeah. Okay.
Matter of remembering the new things before I forget the old things.
Yeah. Yeah. So, coming back to the developer experience of Janaga.net, this is what what all of that was there to enable. And the last time we talked, the watch syntax was a little bit clunky. So it's simplified, and there's some convenience in there as well. So here I've got the watch. So it used to be that you would have a lambda here of some kind of a config thing, or I called it observer. So observer to observer, and then do the dot on added, and then you could do a dot on deleted and all that stuff. So now it's just the results. So now you give it a lambda of the result, which is going to be one of these objects here. So actually, if I gave it a name, then you would actually get result of that name. But yeah, that means that now you've got results dot names is that thing, and result dot person. Oh yeah, insert person really should take a result dot person, shouldn't it? But so you've got those objects available to you in here, and so you just have the lambda of, okay, what do you want to do with it? And then last time we talked, I did talk about that it returns the lambda of what you want to do when you delete it. And what
the lambda of what you want to do when you. Now I don't follow.
Okay, yeah. So so the way to kind of read this is whenever a person is added to the family, then you'll get that right here. In fact, I don't think you've got. You don't have a rename inside of here, but I could call this person. And so if I were to do insert person, then here I would expect that. So, yeah, that's why I called it result. It's because now you've got person, that person. Yeah, so whenever a person is added to the family, you take one of these objects and you call this this lambda with that object. So you've got a person and you've got their names. And so this particular watch is intended to keep a projection database up to date. So anytime a person is added, then you're going to call insert person, and that's going to give you back a person ID because you're using that auto-incremented ID inside of your projection database. And now let's skip over this part for a moment, and let's go straight to this. Is that when that that person is somehow removed from the family? So let's imagine that there were a where clause up here. That some event could happen that removes a person from a family. And so when that event happens, then the watch is going to call this lambda down here. And it's going to call it with, it's going to call the specific lambda that was generated when that person was inserted. So that means this person ID that you captured into that lambda, that is preserved and that's consistent. So does that part make sense?
A little bit. I will have a look to it later on.
Okay. And then what I'm trying to do is, yeah. Okay. So we've got the person ID that we inserted, and then if there was a where clause here, that it could become true, then that or could become false, then that person could be deleted, and it would call the delete person with that same person ID. Now this one, the query actually can produce this effect. So person.names, it's going to be names of person. And so if you go in there and you create a new person name fact, so a person has changed their name. They've changed it from prior to current. And so you're going to get a new person name fact, and that's going to cause person names on added to be executed with this person name. And so now here we can do the update with that same person ID. So we've captured that person ID into this lambda. Yeah, that's the idea of closure. And then we're taking that new value and we're putting that into the database. So this this little bit right here is actually no longer necessary. That was one of the convenience things that I added, is that the most general way that you could do these on added is every single one of them is async and returns an async delegate. But sometimes you've got to do nothing. So it's like, well, okay, let's go ahead and let you just return. And then sometimes what you're doing is not asynchronous at all. So in addition to that watch, I might do aj.watch for people in family. And now I'm going to go back to using the name result because, yeah, it contains more than just the person. So now here I'm not going to use async. And that's because what I want to do in here is update the user interface. So I might say, yeah, I'm going to create a person component on the user interface. So let's whatever that thing happens to be, I'm going to have a function that returns one. Let's even be more explicit about it. Okay, so yeah, it caught up. So this would be something. Back. Oh, okay. Sorry, I wasn't keeping an eye on the time. It is that time, isn't it?
Yeah, it reminds us every time.
Okay, so so this here creates a person component on the user interface. So maybe this adds it to a list in a view model, and you've got it data bound. Whatever mechanism you're using to update the user interface. And so that's why this one's not async, but it still works. It still compiles. And behind the scenes, it's just turning that into an async method that returns a completed task, and just gets rid of all of the boilerplate, so you can use the most general solution. So now you've got your user interface. It's updating these person components, but you can't see their name update. So what you then do is you say result.name or names dot on added. Then I've got the person name, and I just simply say person component dot name equals name dot value. So maybe I've got that as an iNotify property change type of property, right? So it's so you've got something like that going on, and you're raising iNotify property changed, or using a sysdigant, or whatever you choose to do. So so now this sets up the binding of the watch to the user interface, and it's all the same watch function and the same on added. And so when a person leaves the family, you want to remove them from that list. So now you can return a lambda that that calls remove person component. Oops. And so remove person component takes a person component. And it just drops it from the view model, and doesn't show it on the user interface anymore.
It's real-time update.
Yep. Yeah. So now with the same syntax, you can do something asynchronous, like keeping a projection database up to date, or something synchronous, like keeping the user interface up to date. And it's all the same syntax. So does that help?
So that is nice. See how far we get with that. But that projection database, that's actually if you want, for example, to connect to another system, to export data.
Yeah, exactly. Yeah, so I could very easily see these async methods here are publishing events on a queue, and then that external system is pulling those events, or making RESTful API calls, and so that's where we get into some journaling and retry logic and error handling, and I'm kind of on the fence. Do I want to give you journaling in the library? Do I want you to just write whatever journaling makes sense for you, or middle ground? Do I want to give you a separate library that does journaling? And does it work with the same transaction? It seems like it would have to. So if you are, so if this Janag object right here is backed by a SQL database, so the actual facts and edges and the graph is stored in SQL for Janaga, then it could begin a transaction when a fact is added and store it in its database, and then call all of these asynchronous watches, and if none of them throw an exception, then commit that transaction. And then all of these could enlist in that same transaction. And now you've got a transactionally consistent projection.
That's, yeah.
And so,
and now the question is whether you want to the export of these data to be inside a transaction as well.
Yeah. And I can see that being something that you would want to do in some cases, but not others. So it seems like that's a contextual, a situational decision. But then the other part of that is journaling, and that is that this process is going to end, and it's going to start back up again. What happens when you start the process again and you hit this line of code? If you don't have any kind of a journal, then it's going to run that query, and it's going to say, oh, okay, I need to insert all of these people that are returned from that query, and it will insert duplicates in your projection. So clearly you don't want that. So what you really want to do is to have a journal where what's happening behind insert person is that it's taking the hash of that person fact, looking it up in the journal and seeing, did I already do this? If so, here's the ID. And so restarting the process just refreshes all of these lambdas here. So now you've got the ID inside of the lambdas here, inside of the lambdas there, so that if you now get new information that's not yet in the journal, then you can act on that information.
Actually, that would be just a reference and journaling table with the hash of every fact that you want to export.
Yeah. Yep.
Might be useful, because otherwise if you send duplicates to external systems,
Right.
they are not idempotent, you get into trouble.
Right, exactly. Yeah, so if you're using the journal just to protect your own projection, and you can do that transactionally, then that's one thing. Okay, now you've got a transactionally consistent projection. But now if you use that journal to protect the remote system against duplicates, now you've got the outbox pattern. So that's precisely the pattern that I described in the book, is that you keep that journal just before you make the API call, get the result, update the journal, and then go about your day. So that narrows the window of a possibility of duplication. Doesn't eliminate it in that case, because that remote call is not enlisted in a transaction, but it gets it smaller, as small as it can be.
Because anyway, I'm gonna need that export, because every time I generate, a technician is doing something. Not every time, but every time he finishes a job, the results will be exported to a kind of accounting package.
Yeah.
And so they do accept some XML files with the data, but so that will be probably on a watch.
Yeah.
And I better don't send it twice.
Yep. Yeah, exactly. And so, in this case, the example that I showed is the same specification used in two different watches. In that case, you would have different specifications. One that's a lot more detailed for the user interface, and then another one that's only concerned about completed jobs for the accounting integration. And so you would use the more coarse-grained specification in this watch, and that would only pick out the events that you're interested in there, and you would make those API calls. Yeah, and so these methods down here would first go to the journal, then make the API call, then update the journal. So I think that once we get that done the first time, we should be able to see some patterns in that code that say, oh yeah, if we were to extract this pattern, make this a library, now it can say, with journal, and just decorate the the insert person with a journal insert person, and it would be kind of like memoizing a function, except this is memoizing a function that is transactionally consistent within a storage database with your journal. So anyway, that would be cool. Well, in that case, it wouldn't be transactionally consistent. It's an API, but it's a persistent memoized version of the function, which is probably more confusing than it needs to be.
No, what I need to have is all the data. I set up separate watch with a specification that's going to collect all the data that I need, and all that data has to be consistent. So I need to, that there cannot be any change in between.
Right. Yeah. So one nice thing about this syntax is that it because you have to have the person ID before you can create this lambda or this lambda. It kind of has already built into it the constraint that insert has to happen before update and before delete. So it knows the partial order, and that's baked into the language. You can't use person ID before it's declared, and so we're basically taking advantage of that language feature to make sure that we have the partial order of these operations match the partial order of the historical facts themselves. So yeah, when you say, okay, I've received this notification that the person name has changed, absolutely, by the time you receive this notification, that they've already been inserted. That transaction has completed and it's committed.
Yeah. And
that's the only way that you could have gotten back that person ID. So yeah, you don't have to worry about the commutative property on your side. That's baked into the watch syntax. You just have to worry about item potency, and that's what the journal is for.
Because even I might have one external package that is protected against repeated, that is item potent, in fact. But I will have to connect to multiple different packages.
Yeah.
So one of them is certainly not protected, and then it might be better to take care of that protection ourselves.
Yeah. In fact, even if the downstream is protected, I would still do the journal, because you don't want to send all of your database every time you restart your application. It's like, oh yeah, here you are. I already know. You can run it against the journal, and then just make the calls that need to be made. But yeah, they should be idempotent too, but you still need the journal.
You're not every time going to start from zero.
Yeah, that would definitely be bad.
Because somewhere that state that it has been sent will be stored, no?
Yes.
Because we actually have a queue. We'll make a queue of let's say, XML files that have to be sent out.
Mm-hmm.
Wait, because then it becomes an XML file. It's not a queue of facts anymore.
Yeah, and that's fine. Basically, what you want to do is make the asynchronous method that's happening inside of the watch get you to the next point of persistence. So if that next point of persistence is an XML file in a folder, then that's fine. So write the file, and now your async is resolved. And so now you journal around that, and so that protects you from just regenerating those files every time. But once the file is generated, you're finished. There's another process that's now doing what it needs to in order to take those files, move them to the target system, confirm that they got there, rename the file so that it doesn't send it again, all that fun stuff.
Yeah, but actually every time, for example, a task is finished, an XML file is created, is placed in the queue, the moment that XML file is uploaded and it's persisted at the client side, we will take it from the queue, we remove it from the queue. That means that if my software restarts, it's not going to generate all the XML files from zero.
Right, yeah, so that's why you still need the journal in front of the queue, even though the queue is still on your side, and it's just a folder full of XML files. Yeah, so yeah, you never really get away from journaling.
Yes, to avoid accidental duplicates, but actually, because like we work in historical modeling, somewhere in the specification is built in. How did you express it? The queue was in the book. You expressed it very nicely. The state was actually in the queue.
Yeah. So the the fact that you have acted upon this thing also removes it from the queue. I mean, it's capturing that one successor fact removes it from the queue as well as captures the results. So yeah, that is I would say that's that separation between the topology and the data model. That topologically speaking, you're concerned with getting information that's in a queue on this machine over to that machine and making sure that it made it before you remove it from here. And that is a problem that that other systems already have solved. So if you're using RabbitMQ, that's done. If you are using XML files in FTP, then there are systems built on top of FTP that do that and do the renaming, and they follow the right patterns. And those are outside of the historical model. But when I talk about capturing the results of an operation and that removes a thing from the queue, that's really the business process. So yeah, I wouldn't use that queue pattern in order to implement a topological queue. It would be, I think, a pretty inefficient way to go about that.
It's confusing me.
Yeah, I think a good example would help. So, and unfortunately, we're actually over time, but so I'll quickly put this in your brain. So let's suppose that as a business process, I am looking at the orders that have come into the warehouse, and it's my job to pick the items and put them on a truck. And so so I do that, and then I put them on the truck, and I capture an event that says that this order has been picked and it's on that truck, and
Yeah.
Maybe I even have a shipping number at that time. So that is stored in the model, and that means the next time I go to my screen in order to look at what do I need to pick, that order doesn't show up anymore. But
Yeah,
that
because
is different from putting something on RabbitMQ and having it send the message. It's a different kind of queue.
because I could add the fact that it has been sent out to the external system.
Mm-hmm.
But there we are mixing the XML files that are created in a watch with facts that we add to the system.
Right, right. Yeah, and to my mind, that that type of infrastructure detail is too low level for a historical model. Even though you can see the parallel, and you can see that you could actually make that work, that makes the historical model far more chatty than I think it needs to be. Nobody else is really interested in all the details about file transfer. It's not part of the problem domain. So by keeping that outside of the historical model, you can then choose your implementation detail. You can choose some other software package that does file transfer. And you don't have to worry about muddying the waters. And because the historical model drives the infrastructure, if you then take infrastructure events and put them back into the historical model, you could actually end up writing a query that just gets you into an infinite loop. You probably wouldn't, but it's possible that you could. So I think it's best to just keep those ideas separate.
Okay.
Yeah.
I will think about that. Okay.
Okay.
Michael, thank you very much.
Thank you very much, sir.
Next week, Monday, you're back again?
That is correct. Yes.
Yeah. I should be back here by next week, Monday also.
All right, excellent. Well, enjoy your trip.
Have a nice day. Okay.
Indeed.
Bye-bye.
Bye.